Okay, so we're going to look at the 2016 AP Physics C FRQs, and we're just going to again do a quick overview to help you a little bit with your homework. So the first thing you do is you're going to look at the picture, and you see it's a cart, with the string and everything like that. Now the first part is to draw the free body diagram. So these are the easiest points you're going to get on the AP test. So again, with the free body diagram, a free body diagram only shows the forces, okay? And it only shows the forces acting in the direction in which they act. Now, one of the things that now they do is they put the box. So in this case, if this is being pulled here, there's going to be tension in the string. And if it's accelerating this way, that means the tension is going to be greater than the friction, because I think in here it says, or there it says friction's is not negligible, which means there is friction. But if it's accelerating this way, the tension's going to be greater than the frictional force. And then of course here you're going to have the weight acting down on the normal force, and you would make those the same size. So again, the size of the arrows are important, but the length is important for you to draw. So that's pretty easy. Now again, a lot of times they like to have these graphs. So here's some data. So it says, I think part B is on the next page. So here's the data. And it says to plot the points for the graph. So the straight line from the graph is always going to be the slope. So first you have to find the slope. So by then you can use the units to figure it out and see what physically that represents. So remember, slope always is the change in y over the change in x. So what I would do is I would look at, I know slope, and you always want to do this when you have a graph, delta y over delta x. So here the slope is the acceleration, which is meters per second squared, because I already have the graphs for you. And then the force is a Newton, where a Newton is a kilogram meter per second squared. So I see that this cancels with this, so I get 1 over a kilogram. So the slope represents the reciprocal of the mass. So the slope is 1 over the mass. So the mass would be 1 over the slope if I wanted to find the mass. Okay? So what you do here is, again, you're going to plot the points, what they give you, pretty simple. And then you find the mass by finding the reciprocal of the slope. So it says, using the straight line from the graph, calculate the mass. So the mass is the reciprocal of the slope. And after you draw the graph, what you're going to do is you're going to do a best fit line. You're not going to connect the dots. And then you're going to show y2 minus y1 over x2 minus x1. And substitute in values and do that. So that's pretty easy. Here, we already did that. Part C, determine the acceleration. So in this case, again, whenever you see the word acceleration, and we're talking about forces, you're going to think about Newton's second law. Summation of F is equal to ma. Okay? And we want to find the acceleration. I think there was some other stuff here that we had to find from the graph, like f of f is the x-intercept. That's where the line crosses the x-axis, so you have to read that. So then, I know by looking at my free body diagram that I did on the first page, I had the tension minus the frictional force is equal to ma. So remember, I want to find this. So I'm going to use this that I calculated before. And then I'm going to use the other values and I'm going to solve for the acceleration. The next part, the string breaks at t is equal to 2 seconds. Calculate the time it takes to stop. So if it stops, that means that the final velocity is 0. Okay, they tell you that the t is equal to 2 seconds. So obviously here we're going to have to use kinematics. So again, we can use one of our kinematic equations. If I use Vf is equal to V naught plus AT I can find VF, or, yeah, but we're going to use kinematics for that part. All right, and I'm going to go over these in details on another video. I just want to give you a head start here. And then for part D, will the slope of the line be greater than equal to, but a greater force of friction? So you look at where you solve for Newton's second law, how does that change and everything like that. And then, or does it change? And then the next part, will the horizontal intercept be greater than or less than? Okay. All right, so that's the first one. That one actually isn't so bad at all. All right, so the second one, again, they're asking us to draw free body diagrams. These are like the easiest thing ever when you're drawing free body diagrams. But first of all, there's something key here. This is a non-linear spring. Okay, so we know that a non-linear spring does not obey Hooke's law. So first we're going to draw the free body diagrams. That's easy. The only thing on the free body diagrams that you need to do is, because this mass is bigger than this mass, you want to make sure that you have the weight going down here is longer than this one. Okay? And the same with the normal forces. And remember, the normal force is going to be equal and opposite. So again, the arrows need to be the same size if the forces are balanced. All right, so now derive an expression. So they collide, so there's a collision. So the first thing you're going to think about is when you see the word collision, the first thing you're going to think about is momentum. Okay, so we're going to do conservation of momentum. So when you do conservation of momentum, you're going to say, well, what kind of equation is this? You know, I mean, collision. So here, you know, they stick together and they move off with one velocity. So you have the 3m times v naught plus 2m, which is initially at rest, is equal to, they stick together, so you have 3m plus 2m times vf. Now remember, on the AP exam, and again, we're going to practice doing the online one, so prepared for the online exam this year, you need to write more stuff out. I don't know how it's going to be on the computer. We're going to have to look at some practices, and they're going to tell us this week. So you rearrange all this and you solve for VF. For part C, determine expression for kinetic energy. Well, the first thing you're going to say to yourself is kinetic energy is 1/2 mv squared. Well, if they're stuck together, you know, it's 1/2 the total mass, and then whatever this comes out to be, the final velocity in terms of v naught. Part D, derive an expression for the maximum distance the spring is compressed. Well, this is a non-linear spring, okay? So this is where you're thinking about work is equal to the change in energy. They just told us something about kinetic energy, so now we know that work is equal to the change in kinetic energy. Now, this one has calculus, so this is equal to, we're going to have to integrate f dx. So what we're going to do is we're going to go back and we're going to use some of the information from part C, and we're then going to put that in here. So you're going to say work is equal to the change in energy, and then you have to integrate. Not my favorite part. All right. Then part E, in what direction is the net force? So then you're going to answer those questions and look at all those. Okay, so remember, one of the things is we don't have simple harmonic motion on this, so I think there's a question about simple harmonic motion, which we're not going to have on the test this year, but remember, it's a non-linear spring, so it wouldn't exhibit simple harmonic motion. All right, so this one, so when the kids saw this one, they cried. Because they were looking at this picture and they're like, we never did anything like that. The problem with this was when the kids were looking at it, they weren't looking in the correct orientation of the picture. So am I looking at this from a top view Or am I looking at this from the side view? So just the fact they looked at the picture and they thought, I've never done a problem like this. And then they saw this stuff with moment of inertia and they were like, oh my God, this problem's impossible. So first, you don't have a heart attack when you glance at the diagram, okay? So read it and think about what is the orientation. So a uniform rod is one end fixed horizontal frictionless circular platform. So you're looking at this from above, okay? So as this is going around, you know, remember the center, here's the axis of rotation. So here my axis of rotation is closer, here it's further away. So we know the moment of inertia is going to change, you see? So don't have a heart attack when you see all this. Think about like an ice skater with her arms and something like that. So again, if it's moving in a circle, there has to be a centripetal force. You have to think about that. Whenever I see a circle, centripetal force. I see there's a spring. Whenever I see a spring, I'm going to say Hooke's law, as long as it's a linear spring. So anyway, there's a couple of things like that we have to think about. So first of all, it says derive an expression for the spring constant. So the first thing I'm going to say, well, I know from Hooke's law, I know that F is equal to minus kx. Right now, don't worry about the negative sign because you're solving for k. So when you rearrange that, k is equal to F over x. Well, what do we know? We know that x is equal to what? D over 2. What else do we know? Well, it's going in a circle, so the centripetal force is mv squared over r. We also know centripetal force is m omega squared r. Remember, v is equal to omega r, and r is equal to 2d. So when I put all this stuff together, and that's why I'm doing the first part for you, the spring constant k is m omega squared r over d over 2. Then I substitute the r for the d, so I get m omega squared 2d squared over d, and then I simplify all that, and it's m omega squared. Once you start doing this, you say, hey, this really isn't so bad. But you don't look at the picture and have a heart attack. All right. And remember, we want to try and get some points. So then it says, determine an expression for the rotational inertia of the block around the axis of the platform. So we want to find the moment of inertia. So the moment of inertia of the block is mr squared. So for the block, it's going to be m. Now I'm going to look at the values, 2d squared. So it just comes out to be 4md squared. For the next part, I, what does it say? Derive an expression for the rotational inertia of the entire system. So the entire system is going to be what? So the total, I just have to find the moment of inertia of the block plus the rod plus the platform, and they give me all the moment of inertias. So now I just found the block, so I got that. So I got this over here. So now I have to do the rod. So the rod is going to be m d squared over 3, and that's the mass of the rod. I should have done, here, let me write this over. The mass of the rod times d squared over 3, plus the platform is going to be the mass of the platform times r squared over 2, but I have to substitute that r is 2d. So then this would be 2d. Well, let me just substitute in the values. Oh, this is kind of a mess. Let me take a new piece of paper. Oh, that marker really went through. So I total is equal to I of the block plus I of the rod plus I of the platform. So we already found in the first part that was 4m d squared. Then for the rod, it's going to be 3md squared over 3 plus 5m 2d squared over 2. And I just add all that stuff up and I get my answer. So that's not bad at all. All right, determine an expression for the angular momentum. Well, what's angular momentum? L is equal to I omega, okay? Which then part D, next page, derive an expression for the distance the string is stretched in the picture above. So with Hooke's law, I know that F is equal to Kx. The force is the centripetal force, which is mv squared over r, and that's equal to Kx. Well, I know that V is equal to R omega, and K is equal to 4 M omega squared, because I found that before. One of the things about the AP exam, whatever answer you use for A, you use for B. Whatever you use for B, you use for C. Whatever you use for C. So if I don't know what to do in a certain part, say, hey, what did I do in the last part? Because I'm going to be using that. So when you substitute all this stuff in, you get like M omega squared R squared R, whoops, is equal to 4m omega squared x, because you know that R is equal to D over 2. Anyway, you have to get it all in terms of x. You have to do some substitutions there. And then you just answer the other parts about as things change. So I just did that to give you a little setup to help you with starting, because a lot of times people are like, I don't know how to start this problem. Again, this one, I don't even know what the average score on that was. It was like something really low because people had a heart attack when they saw the picture. And then we'll go over these in detail again. And that's it. And then we're going to start using AP Central.